Standards G6 and 7 are all about Pythagorean theorem. Starting with G6, we are proving the Pythagorean theorem, or we're answering questions that deal with proving the Pythagorean theorem. Number 1, select all statements that are true. The first, the angles in a right triangle are always 30, 60, and 90 degrees. That is not true. They do have to include a 90-degree angle, but the other two could be any combination that add up to another 90 degrees. The second is, given a right triangle, if you pick any two side lengths, their sum equals the length of the third side. That is not true. You have to deal with squares of sides. The next one, if a triangle has side lengths of A, B, and C satisfying the equation a squared plus b squared equals c squared, then it must be a right triangle. That is true. If it fits Pythagorean theorem, then it is a right triangle. The next one, in a right triangle, the sum of the two non-right angles equals 90 degrees. That is true. And then the last one, all right triangles are similar. That's not true. One angle has to be 90 degrees, but the other two could be any combination that add up to 90. Number 3, a right triangle has a hypotenuse of 25 centimeters and one side length of 7 centimeters. Use the Pythagorean theorem to find the length of the third side and show your work. So Pythagorean theorem says that we take the sum of the squares of the two shorter legs, and it's equal to the square of the longest leg, or the longest side, which is the hypotenuse. So we have a hypotenuse of 25 centimeters and one side length of 7 centimeters. Let's call that side B. It could be A or B. So we'll simplify. And now I want to get this a squared by itself, so we'll subtract 49 from both sides. We're just solving an equation. And get that a squared is equal to 576. And then to get a by itself, we're going to square root both sides. And a comes out to exactly 24. So that third side is 24 centimeters. Number 6, triangle DEF has side lengths of 5, 13, and 12 centimeters. Use the converse of the Pythagorean theorem to prove that that DEF is a right triangle. Write numbers 1 through 4 in order to order the steps. So for using the converse, it's just saying that if it fits a squared plus b squared equals c squared, then it is a right triangle. So that's our first step. So now we got to plug in our numbers. The longest side is 13, so it has to be C. A and B could be 5 or 12. I'll go ahead and plug in 5 for A and 12 for B. That's that second step. Now we're just going to simplify this. That's 25 plus 144 to see if it's equal to 169. And now further simplifying, 25 plus 144 is 169. So both sides are equal, and we have proved that it is a right triangle. And G7 is focused on using the Pythagorean theorem. These are the most common questions you think of with Pythagorean theorem, where you're often given a triangle or given a word problem and you're finding the third side. So we're going to start with this problem number 2. Find the missing side length to the nearest tenth of a centimeter. So I'm going to start with Pythagorean theorem, a squared plus b squared equals c squared. And if there's any doubt about which side is C, take your right angle, find the side across from it, that has to be C. So that means 8 has to be C, 6 could be A or B. I'm going to call it B. We'll call that the missing side A. And so I'm going to solve this. We're going to start by simplifying. We get a squared plus 36 equals 64. Then we want to get a squared by itself, so we'll subtract 36 from both sides. And the result is a squared is equal to 28. And then square root both sides. And a comes out to 5.291 ... But to the nearest tenth of a centimeter, we think, okay, the tenths is the digit after the decimal. That 9 will make it round up. So 5.3 centimeters when we round. Number 3, the size of a TV screen is usually described by the length of its diagonal. In Part A, if a 54-inch TV screen has a width of 43 inches, what is the height? Round your answer to the nearest inch. So I'm thinking of a TV screen. I know it's in the shape of a rectangle. And we're describing the diagonal as 54 inches. We know it has a width of 43 inches. And we're looking for the height. We'll just call it x. So notice this does create a right triangle within this. So I'm just going to set up a Pythagorean theorem where 54 is c, and we'll call this a squared plus 43 squared. Simplifying, 43 squared is 1,849, and 54 squared is 2,916. So we'll subtract 1,849 from both sides, and we get that a squared is equal to 1,067. And then square root both sides to get that a comes out to 32.6 ... 66 ... And to round to the nearest inch, that's 33 inches. Part B, what is the area of the screen? Round your answer to the nearest square inch. Well, we know area of the screen, which is a rectangle, is equal to base times height or length times width. And we know it was 43 times 33, and that has been rounded. And so we'll just multiply that out, 43 times 33. I get 1,419, so the answer is 1,419 square inches. Number 11. A wizard walks into a wand shop to purchase a magic wand. He chooses a wand that is 22 centimeters long. Will the wand fit into the box shown, and explain? So in this problem, we need to know if it will fit diagonally in this box. So it needs to be less than this longest possible diagonal that goes from corner to corner within this three-dimensional space. To find that, I have got to take this little triangle here and solve for C, that diagonal we're looking for. So I know that the height here is 5, and I don't know this value. This value is unknown. I'm going to call it x. To get to that value, I know 21 and I know 6. So I'm going to start over here by using Pythagorean theorem, a squared plus b squared equals c squared. We have 6 squared plus 21 squared equal our unknown c squared. 6 squared plus 21 squared is 477. And then we're going to square root both sides. And I'm going to leave my answer in radical form, square root of 477. So that is this value here. So now I'm going to take that purple value here that we've just found. We're going to plug in once again, a squared plus b squared equals c squared. We've now got the square root of 477, which will square, plus 5 squared equal the unknown we're looking for, c squared. So when I take the square root of a number and then square it, they just cancel out, and I get 477. Plus 5 squared is 25. Adding those together, we get 502 is equal to c squared. And then square rooting both sides, c comes out to 22.405 ... So about 22.4 centimeters space in the box. Okay? That was this value right in pink. It's 22.4. That's what we were looking for. Now the wand is 22 centimeters long, so will it fit? Yes. It's smaller than the box. Standard G8 is still using Pythagorean theorem, and we're going to apply it to distance. So we're going to find diagonal distances between points. Starting with problem 1, find the distance from point A to B. Round your answer to the nearest unit. So we want to know this distance. In order to find that, we need a third point. Now, I could do this a couple different ways. I could look at point A and say, well, okay, that's the point 3,2. Point B is the point 7,8. I could take the x-coordinate from point A and the y-coordinate from point B, 3,8, and I've got a third point. I could also take the x-coordinate from point B and the y-coordinate from point A. I get the point 7,2, and there's a third point. So I could use either of those to complete my right triangle. I think I'll take this top one. The point of that, though, is to get a third point that is directly across from one and above or below the other to make a 90-degree angle where you have a vertical and a horizontal leg that you can count. So the horizontal leg is 4 units across, and the vertical leg is 6 units tall. I'm plugging in to a squared plus b squared equals c squared. We've got 4 squared plus 6 squared equals c squared. And simplifying that, 4 squared is 16, plus 6 squared is 36, which adds up to 52. And when we take the square root of both sides, we get the square root of 52 is 7.21 ... So to the nearest unit, that is 7 units. Number 2, what is the perimeter of the triangle? Round your answer to the nearest unit. I'm going to have to find these 3 diagonal distances and then add them to get the perimeter. So I found that last distance, or that first distance, sorry, it's the square root of 53, and I'm just leave it in square root for the sake of finding these the perimeter total in just a minute. Now we'll get this left side. Okay, so using Pythagorean theorem, we find that side to be about the square root, or to be exactly the square root of 82 units long. Okay, and we'll apply the process one more time to this bottom right side, and we get that side to be the square root of 85. Last, we're going to add these 3 sides together to get the perimeter. And I just type them in my calculator. I get 25.55, and it keeps on going. To the nearest unit, that rounds up to 26 units. Number 3, select all the points that can be used to find the distance between the points 4,1 and 3,8 using the Pythagorean theorem. You only have 2 points that you could use. They have to have the x-coordinate of one of the units, of one of the ordered pairs, and the y-coordinate of the other. So 4,8 would be an option. Or they could have the x-coordinate of the other ordered pair and the y-coordinate of the other. So 3,1 is an option. So we'll call that choices B and D.